Hey, hello Math 10. We're going to be taking a look at some really hard questions today. We're going to call these Exponent Master questions because they're about as hard as it gets, and they're definitely going to test your understanding of the exponent laws. And I can remember when these questions used to be in grade 9 math. This was definitely a grade 9 math type of question that was always sort of a big deal. When grade 9s would get these, they'd feel very happy to get the questions right. And I actually can remember seeing these in Math 12 as well. There's similar questions in Math 12 that they give as review questions. So lots of pride to come from conquering these questions, so to speak. So just to get started with, I want to give you a bit of a game plan of how to approach these questions. There is some art to it. You don't have to do it exactly the same way every time. Sometimes you can find some pretty clever shortcuts or just creative ways to make the work simpler. So I'd love to hear about any kind of cool things you come up with that make your work either easier or just you feel is a clever way to do it. I'll show you my game plan. That's just sort of a, just do this and it'll probably work for the most part. So first of all, I would start with a power rule almost always. So what do I mean by that? So, like multiplying the exponents that are outside the parentheses into the parentheses is going to be an important first step. You can't really do power rule or, you can't really do product rule or quotient rule until that's done. So you're going to want to make sure you resolve these parentheses first, or you can't get much stuff done. There might be some odd exceptions, but that's a good start. Next, after I've cleared all the parentheses, I'd probably simplify the numerators separately from the denominators. So I'd use product rule to kind of multiply across if there's anything to do there. I don't know. That's just personally for me. I think it looks a lot better when it's all sort of each part of the fraction is simplified. And then afterwards, I'll use quotient rule to sort of vertically do my division and subtract exponents from like terms. And last but not least, then I'll deal with the negative exponents. So I'm like, oh yeah, negative exponents. Don't really like to deal with them in the question, although you can totally anytime. But I'll just deal with them all at the end. And don't forget that these questions aren't really right if you still have negative exponents in them. You've done, possibly all these other steps correctly, and on a test you might get, part marks for that for sure. But definitely make sure that your test questions have no negative exponents in the final answer. So we're going to use the negative exponent law to move those exponents out of the denominator and into the numerator, or vice versa, in order to flip the sign on those exponents. Okay, so let's take a look at an example or two. We'll take a look at, say, the first question. So, like I say, first step I would do is power rule. Now watch out, there is a big trap that I've seen grab students all the time. Don't forget that you're multiplying this outside power, so for example this one will be -2. We're multiplying it onto all of the exponents inside the parentheses, and that includes on the 2. The 2 has an invisible exponent of 1. So we're going to multiply that -2 onto all of the exponents, onto the 3 of the B, onto the 2 of the A, and also onto the 1 of the 2. So you need to multiply it into everything. So don't forget those sneaky invisible 1 exponents and include those in the power rule. So if I do the power rule, I will get, for the first question, I'll get 2 to the -2 and A to the -4, B to the -6. And that's going to be times. So I'll do my multiplying the power of 3 into here. I kind of missed there with my arrows, but hopefully it makes sense. So that's going to be times 4 to the power of 3, A to the power of 3 because of the 3 times the 1, and then B to the power of -3. And that's going to be all over, and then we'll do our multiplying here. A to the -12 and B to the -4. Okay, so there's our first step. Sorry, my on-screen writing is not very good. I'm working on it. So next step, I'd probably do something like the product rule. So I'm going to simplify that top big ugly numerator and try to multiply together to get like terms. So what are we going to get here? So we're going to get, I guess I'm going to leave the numbers, the solid numbers, sort of on the outside. So I'll leave that as 2 to the negative 2 times 4 to the positive 3. And then, let's see, our a's can multiply together. So we've got a to the negative 4 times a to the 3. So negative 4 plus 3 is going to leave us with a to the negative 1. Okay, so that's okay. And then we're going to do b to the negative 6 times b to the negative 3. So that's going to add our exponents again. So we'll get b to the negative 9. And then we have, on the bottom, we still have a to the negative 12, b to the negative 4. That hasn't changed. That's still the same. Whoa, okay. So now we can do quotient rule. So quotient rule will require us to divide our like terms, and then we're going to just subtract our exponents. So that equal sign, I cannot abide by that ugly equal sign. Let's try again. Okay, so I'm going to just leave my numbers as it is for now. 2 to the negative 2 times 4 to the 3. And then a to the minus 1 divided by a to the minus 12. I'm going to subtract negative 12. So that's going to make it a to the positive 11. And then b to the 9 minus negative 4 is going to be b to the negative 5. Okay, so now I need to sort of move my numbers around. So I am going to bring my negative exponents down to the bottom of the denominator. And I guess in this case, if they were on the bottom, I'd bring them to the top. So this is going to become 4 to the 3, a to the 11 over 2 squared b to the 5. So that's the negative exponent law in action. I'm moving the negative exponents down below to make them positive. And we're still not quite done here. I can see that 2 squared is actually 4. Right? That's actually 4. So I have 4 to the 1 on the bottom, so I can further simplify that. So I could get 4 to the 3 minus 1 gives me 4 squared, which is 16 a to the 11 over b to the 5. Well, I don't know. Am I an exponent master? Probably should have checked the answer before I started. Hey, look, I got it right. Woohoo! So the answer is exactly that, 16 a to the 11 over b to the 5. What a beast of a question. That question is so big, and I'm sorry I did not do a super neat job of it. But that's a doozy. I'm going to say right now that the questions, that's about as hard as it'll get in this unit. So congratulations if you get these and you're doing just fine on them. You know, more power to you. I'm just kind of scanning through to see if there's anything in particular that might get even more scary. Yeah. Nothing like in particular. I'll just mention that like for a question like G, that we're multiplying these things together, these two fractions together. It's not a big deal. Just do your power rule first, and notice when we have these big parentheses, that negative 2 is going to multiply onto every exponent in the numerator and denominator. You can, however, get rid of that negative exponent right away. So a nice way to avoid getting all those crazy negative exponents is just to flip the entire fraction. So, for example, if we just were to look at this part right here for a moment, you could convert this to a positive 2 exponent and just flip everything that's inside. So the numerator goes on the top, so x to the 3y to the negative 1, and 8 to the negative 1, x to the negative 3y. And then you can just multiply in the 2 to finish the operation. So the 2 gets multiplied onto every exponent in the numerator and in the denominator, because the parentheses are super big ones that also cover the whole fraction. So just be mindful of that. So that's a nice way to deal with those negative exponents. I mean, there's plenty of negative exponents inside of the question. So in some ways, I wonder if it would have been worthwhile just to multiply the negative exponent and cancel some of those guys out of there. But it's okay. Yeah. Ooh, look at this one. Look at J. J is a nice one. We got square brackets. Whoa, so that means that there's a power rule going on with this power rule. So just like BEDMAS, probably good to start with the inner brackets first. So I would do, I'm not sure if that's actually the best advice. It's not terrible to do it that way. I don't think it's wrong to do it that way. So I would, I guess I would multiply it. It's a bit of an art. This one is like, the order isn't super important, but I would multiply this in first onto all the exponents. And then when those parentheses are clear, then I could multiply this negative 2, I flip it probably first and then multiply the 2 into all of the different powers that are inside of those big square parentheses. So that's a pretty beastly one. So, wow, some crazy questions in here. I wish you the best of luck on them. I know that they're hard, and I know that will take a bit of time, but they're really good practice. If you can do these questions, then what can't you do, really, with exponent laws? So it's a pretty fantastic way to prove your strength. I think I'll stop there on this video because we've been talking for a while, and I'll let you do some of those questions. There is one other topic to do in 1.5 that has to do with exponents that are fractions. So if your power has a fractional exponent, what does that mean? So we'll come back and do that last video. Okay? Thanks, Math 10. Bye.